Awesome. Hey folks, how is everyone doing today? All right. So we are working through chapter 7. No. We were working through chapter 6. No, we were looking at chapter 5. Wait a second. I'm looking at the wrong class. No. Yeah. These are the PowerPoints for the other class. We want the logic PowerPoints. There we go. And so we were looking at how can we make our conditional expressions much more complicated to solve issues that are more complicated than checking if one thing is true. We had a way to deal with that before, which was nesting our if statements. And so when you are testing multiple conditions, we looked at how you can use the logical operators and, or, and not. But there are times when you need to use nesting to do what you want, and there are times when you'll need to use more, or when it's better to use more complex conditions which involve logical operators. And so if you didn't watch the last video, make sure you check that out because we go over those operators. All right, I think here we go. So we looked at how to do complex last video. You'd have to go back to the video on the if statements, if else, and switch to look at how we did the nested. All right, if you don't know what I'm talking about. This is a good slide. It explains when you should use one over the other. So a complex condition is used when one action performed perform one action when the combined condition is true. So, for example, well, actually, the most important thing here is if you want something to happen when everything's true or when everything's false, and with the not operator, you can actually, check if some things are true and false alternately. So, for example, maybe checking to see if someone has a late fee on their electric bill. I think they give you 30, 60, or 90 days or something. Or I've had bills where they charge you a higher fee if you wait 30 days and 60 days and 90 days. Anyway, we could have a condition that checks if part of your bill is overdue, and we need to know whether it's 30 days, 60 days, or 90 days. and we also need to check which portion is not, and so we can have conditions checking for each bill, how much is still owed, and how long it has been since you paid it last. All right, but you know, if we have basically with complex conditions, you're only ever going to have two outcomes. You can only ever have two outcomes with using a single complex condition. But with a nested if statements, you can have more than two outcomes, right? If you nest an if statement, and if you have an if else, you can put an if else inside of the if, and you can put an if else inside of the else, and that would give you four outcomes, right? So let's take a look at that. And we'll just use some simple examples. If anyone, oh, good morning, Wyatt. If anyone is in the chat, which Wyatt is, anyone else in there, while I'm creating these basic examples, why don't you guys try to think of a case where you need to check multiple variables, but it should only have two outcomes, all right? And then alternatively, think of a situation where you're checking multiple variables, but you need more than two options. Hey, Charlie. So I'll just use some numbers so we can check that. But what do I want? Oh yeah, JavaScript. Nested versus complex conditions. Okay, and I'm going to go ahead and post the link to this in the chat so you guys can look at it after I'm done, or if you want to look at it while I'm working on it, you can do that too. I'm excited for next semester because I've got a lot of prospective students that I know are going to make good web developers. I'm looking forward to you guys getting into the more meaty subjects here. Okay, so I'm just going to use the console for this. So let's say we have money equals 100. And we'll say Bob's money. And then we'll put Sally's money. And I'm not going to put the apostrophes in there because what do you think happens? Because the possessive form of a proper noun has an apostrophe S on the end. But when we're creating identifiers, we're creating the grammar for the computer, and so you don't need to worry about that. And if anyone knows what problem that's causing, go ahead and tell me in the chat. Say Sally is much more frugal with our money, so she has 200, and then we'll go day equals Friday, and payday equals Tuesday. Just get some random junk out there to mess with. Okay, so let's say, I was hoping this would come to me as I was working on it. What can we use with this? Oh, here we go. Let's also have interest compound day equals Thursday. So if you ever have extra money, don't put it in a mattress. Put it somewhere where you're getting interest and forget about it. Even if you can just put $5 a paycheck, it's worth it. Okay. Especially for you young people. If you're my age or older, just ignore all of my life lesson type tips, because you probably have one life lesson tips that would help me even. Okay. So we want to say if these numbers don't need to be here. What could affect? Oh, okay. We'll say the account gives 0.01% interest. So it's not 0.01 or 1%, it's 0.01% interest for balances below 150. Accounts above 150 earn 2% interest. So this is an interest rate that you might probably see in a savings account, 0.01%. It's not a very good interest rate. I don't even think it competes with inflation. But there are some banks, most online-only banks, because they don't have to pay for overhead, can give you interest as high as 1.5 or 2%. Okay, and so that is 200 times more than this. So do the math. Okay. I gotta remember not to type this in Python. So we're gonna check Bob's interest. Ooh, and we can use this for today's lesson if I get to it, which will be methods in JavaScript. Wait. Let's see, what is chapter 8 here? Functions, cross our fingers. Yes, okay, good. Because you're not really programming, and so you're using functions. So, we want to check if Bob is going to, what interest he's going to get, or actually anyone's interest. So, but in this case, we're going to check Bob. If Bob's money less than 150, then we're going to do console.log Bob's money times, and so what would be the formula for this? I want to get his total amount of money after interest is calculated at remember, less than 150 is 0.01. Hey, Alex. So 0.01%, what number would that be? So 1% would be 0.01. Okay. And so this would be 1/10 of the percent. This would be 100. No, wait. Why did I put so many numbers? Yeah, it's two more zeros. Okay. And this should tell us, wow, my replit is breaking. If this ever happens to you, you're going to need to refresh. But if it hasn't saved, you're going to lose everything. So I hit Control A, select all, and then I hit Control C to copy it. And now I'm safe to refresh. And it's still not working. Oh, there we go. And still loading. I know you guys watch these live streams just to watch me watching the screen load, right? All right, well, we'll just fall back on the text editor. How's that? So here's my preferred text editor, Visual Studio Code. It's free. And I'm just going to put this in one file, an HTML file, so that I don't have to track multiple files. All right. So if it's going to be in the HTML, I'm going to throw it in script tags, right? Okay. And then I'll save it. And I'll throw it on the desktop so I know to get rid of it later. I have a plugin that would open this in, there we go, Chrome. Excuse me. All right. Oh, it saved it as a text file. That's not what I want. Right? It's not gonna open in it'll just open as text in a browser if I save it as a text file. So we need to save it as .html. That way the browser knows to actually interpret it as code. Okay, now let's try running it with I use Replit so much for HTML. I could just open the file. I'll figure that out later. So where's my Gigi file? Here it is. We will open with Chrome because we want the, well, it's already set to Chrome by default, but your computer might be something else. So it's up to you how you want to open things. Okay, but it's blank. Well, I'm only putting output into the console, so I have to hit F12. Here's my output. Wow, it's really tiny. Has this loaded yet? Nope. Give it another try. So it's returning, or it's printing out 0.01 because I forgot to add. So he's going to get 1 penny on his money. But we want to see how much he'll have total. So we actually are going to change this to 1.0001. That'll tell us the total, because the 1 represents his starting money, and this is the 0.01%. And we can just refresh it. There we go. He'll have $100.01. Now let's see. Back in the code. So now I want to test if the value is equal to or greater than 150. When will we do arrays? Yeah, what the heck? Must be chapter 9. We're going way faster than the normal logic class, because otherwise it's going to be a waste of time. So I'm going to have to find those files somewhere. They're probably in the class. Let's see. So you guys think about what would be the best way to, I want to have, well, I'm pulling this up and answering Wyatt's question. I want to do this if some other condition is true. There's a lot of ways to do this, but there's one way that's more efficient. So try and figure that out. This would actually be what? 2%, which is going to be that. And so that's a lot more, right? So there are online-only banks that can give you a lot more interest because a physical bank has to hire a lot of people to work. There's a lot more overhead in a physical bank. But as long as you know your online bank is FDIC insured and you have less than $250,000, then you're safe. So after functions we would definitely do. We should really be doing arrays before that. Why don't I have these chapters? Chapter 10. Let's see what that is. Arrays. Okay. And let's just double check what 9 is. I'm not sure why that's being skipped, but might be a good reason, might not. Definitely want to do arrays. All right, chapter 9 is menus and data validation. Okay. That's what we do in web scripting 1, so it makes sense. You know, you can look at it. I mean, you have the book. You can look at it if you want. And I know Wyatt, you've been already doing that in your programs, which is totally fine. All right, so let's, before I go, did anyone come up with an answer to this? If we want to check for the, for the balance of, and use the other percent, what would you do? You could do this. Save it. Okay, so we already know he's going to get $100 and a penny if he only has 100. So let's see if he has 150, how much money he will have. And I keep wanting to use Replit, but it's not going to let me. Oh yeah, we're in Chrome now. There it is. And so he actually gets $3 So by adding $50 into there, he will be receiving $3 if, I think that's maybe in a year, if we're talking 2% APY. If you have $150 in there, and it increases by 2%, it's a lot more complicated than that, because it depends on whether the interest is compounding. I'm not sure if we do an assignment in this class about that, but interest calculations. Keeping track of my own finances is a hobby of mine. I know it's riveting, right? So simple interest calculator. So it's going to take in how much you're starting with, the rate per year, which is your APY, and then you can put in an amount of time, and then it'll figure that out. But you could create your own. If you're getting compound interest, though, compounding monthly, or actually, let's see this. So let's say you have $10,000 and your rate is 2%. And we want to know how much we're going to get in 1 year. And it's compounded monthly. You're going to get $201 in a year if you keep $10,000 in there. Let's say, so that means every month they're going to add interest in based on how much money you have. Let's do daily. If your interest compounds daily, so we got 201.84 before with monthly. Now we're going to say it's compounded daily. You get more because that interest. This also illustrates something called the net present value of money, which a lot of people don't understand. If, for example, if you have a bill that needs to be paid, you might want to get it paid early so you don't forget. Or if you have daily compounding interest, you can wait till the last day to pay it and be earning interest on that money. Anyway, it depends on how much you want to micromanage your stuff to get 3 more cents. But you can also program things to do it for you and stuff. So that makes it interesting for me. I try to leverage my programming knowledge anytime I can to automate things that will make my life more efficient. And so hopefully, if you get through this program, you can do the same thing. On top of getting a job, right? With that job and all the extra money it'll give you, you can put more money away. So you're not destitute when you're 65. Okay, so now I'm just opening random things here. Okay, anyway. So we changed it to $150, so he gets $3 instead of a penny. In the same amount of time, 2 interest rates, 1 penny. So he got 300 times the money with that higher interest rate. It's pretty nice. Here's the problem with this. Okay, let's go ahead and say, oh, okay, we're going to put it like this. So it's less lines. Okay, so it's, 5 lines here? 1, 2, 3, 4, no, 6 lines. Does anyone have a better solution than this? Did anyone come up with a different solution for calculating out, checking the 2 values? Here would be the absolute worst way that I can think of. But it works. So you should never do it this way. And why do you think not? So now we've just, for doing the same thing, we've increased the number of lines. And we've made the code a lot harder to interpret. So let's make sure it works. So we want this outcome, the true statement of this inner if. And we'll put this console.log. This code will never run. So this is the example of nesting it if you're just checking one person's thing, unless you mean something else, Wyatt. You can post the code in the chat if you want. Or if you have it in a replit, you can post a link to that. So I just want to make sure that this works. And where did I put that? Did I close it? I might have closed it. Yeah. Oh, we gotta open it again. Remember, we're outputting to the console, so you have to look in there. So we still get 153. It's still working, but now it's just more convoluted. We can actually get rid of everything like this, because in this case there's only two outcomes. You either have less than 150 or you have more than 150. And in this, doing it this way, it's actually kind of funny. This is the case if the bank is also, if you have a negative amount in your account, they charge you negative interest. I don't know if that's a real thing, probably not. I think they would just charge you exorbitant fees, you know, $25 or $35 or $45. They have laws about how much fees they can charge you. I had a bank once that I no longer bank with, but their fees were apparently over the legal value, and so they actually had to pay everyone back for every fee they charged. Not the difference of what the highest fee is. They had to pay back every fee. It was a bank that preyed on people that they knew were going to make mistakes and get fees. Okay, anyway. Deplorable. Very deplorable business practice. Kind of like Rent-A-Center, payday loans, title loans on your car. Never a good idea. Okay. So this will also work. Whoops, I deleted the wrong piece of code. This is why you should not talk while coding. And then, so I had this in here. This code will never run. Someone tell me why this code would never be reached? Once you think about it. It is actually a complete waste of time to put this in here, to put an else on this case. Tell me a number that would not fit either of these conditions. So for example, are there any numbers that are not less than 150 or numbers that are greater than or equal to 150? Is there any number you can think of? Right. Charlie, you're exactly right. And so I don't know if all of you watching this, here today or recorded, know about Venn diagrams. They are extremely helpful when you're determining these types of conditions. When you have numbers like this, and you just need to compare the difference, numbers that are above and numbers that are below, and it's inclusive, and that's all you need. You only have to include one if statement for that. You don't need a second one. You don't need to nest anything in this case. So it'll work the same if we do it like this. And so remember, you don't have to put a condition on an else ever. It'll break if you try to. What is this saying? This is saying if Bob's money is less than 150, do this. And then what would make the else happen? So the else is just going to, if you think about it as a Venn diagram, the else includes everything that doesn't fit this here. So if this is false, then there's only one right answer. It's that it's greater than or equal to 150, because that's the only possible values that could get you to else here. And that's actually logic, all right? It has nothing to do with JavaScript. That's just logic. Okay. Which is the name of the class, right? So all of this you can apply to any problem solving, regardless of whether it's programming or not. It just happens to be all of our problems that you're going to get from me are going to involve programming. So I guess let's test it so I don't look like an idiot, just in case. I make mistakes all the time. Not perfect. Okay, it still works. And let's just double check that it's actually running the right code. So I'm going to hit Control U to see the source of the page. And it is. Here's the if statement that I have. I learned this after a lot of programming, but you need to ask the computer what it's using. If stuff's not happening correctly, it might just be because you're telling it to do something different than what you actually want it to do. Okay. So anyway, so this is a case where, there's only two outcomes. All right, and so we only need one condition. All right, and so let's use the payday thing now. Why can I not think of it? I think it had examples in the chapter. Let's go back and use one of those. All right. Okay, so age less than 12 or age greater than 65. Okay, so that's if you want to cut out some numbers. Oh, okay. Yeah, you might notice a lot of similarities between this class and the Python class. At some point, I'm going to replace this logic class with the Python class. Actually, you know what I could do? Since now I'm the lead instructor on this class and program coordinator, I think I'll just stop teaching this stuff and put the Python class in here. Maybe, I don't know. Some people like to take that Python class just because they want to use Python in... Well, then I could take the logic class. Yeah, that would be better. Then I could fit something else in for the Python class. So what other conditioning things do we have? All right. Dean's list criteria. Oh, we already did that one. So anyway, we can just look here at one of the examples. So you don't have to wait for me to go through it. All right. So here we could do, let's break this down into a worse structure. So that way you can identify the way not to do it. So let's get rid of all this. Actually, let's get rid of it. We don't need that anymore. So we want to check this condition. And so we can set age equal to 1 for now. And I think I was probably declaring my variables like we do in Python, sorry. So remember, we want to use the keyword. Otherwise, in these small programs it doesn't really matter, but it does if you have a larger program where names might be reused. And JavaScript, if you use var, it's very close to a global variable. It's not exactly, and so it can cause problems in a larger program. Okay. So we could do it this way. This is what we learned. Okay, so if age is less than 2, or, oh wait, that's Python. Here we go. Or, so remember, 2 vertical bars, that's or. Let's see. Why? Let's take a look here. I don't think you're wrong. It's just you did money less than 500 and money greater than or equal to 500. I'm not sure. Did I say anything about that? I think you might have been solving a different problem. But the example that I did is for just checking whether the number is lower than 150 or greater than or equal to 150. Oh, that wasn't the best solution. I never followed through on that. Okay, let's go back. All right. And so this way, because there's 2 outcomes, we can just use if and else. Oh, wait, never mind. It has to be 2 outcomes in this case. If you're looking for numbers within a range and outside of a range, instead of just this case, you could do it that way. But in this case, we actually need code that's going to do 2 different things. So we need to have basically check, here's what's going to happen on this condition, here's what's going to happen on this condition. So in actuality, that was the best way to do it. Okay. And so I don't know how this is going to look in the chat, but I'll go ahead and post that because I usually comment out my code and don't delete it, and so it gets very messy. But you'll thank yourself if you prevent. Well, it's kind of like that thing where if you never have problems, you'll probably think, oh, why am I doing all this extra stuff? And then as soon as you stop, you'll be like, oh, now I know why I'm doing that. Kind of like if you brush your teeth every day, and you never have, cavities or anything, it may feel like a waste of time to brush your teeth. But if you've had a cavity before or had to have dental work done, then you'll wish you had brushed your teeth. Okay, brush your teeth, guys and gals. It's very expensive. Dental work is very expensive. Okay, and painful. And toothpaste is a lot cheaper. What am I doing here? Oh, I'm putting this in the chat. Yeah, that's not how I wanted it to look, but you guys can fix it if you want it. And so let's go back to, oh, and then I lost my whatever we're doing. Okay, understanding how the undo and redo work is important. How they work. Yes. Okay, so I'm gonna copy this again. I just want to show you guys that there's a lot of different ways to do this, and here in the beginning, you're gonna just try things until it works. I know that you guys are doing that, and that's fine here in the beginning. Trial and error, probably one of the slowest ways to learn things. in programming. But sometimes that's all you have. Once you expand your vocabulary and you understand how to use resources like Stack Overflow and documentation, and using debugging tools and stuff like that, you will be able to have the computer tell you exactly what's wrong, and then you will know how to fix it, instead of just changing things around because you're not sure if the syntax is right and you're just trying to get it done quickly. So here we have this. Remember the symbol for or is 2 vertical bars. Okay, and then we need to let age equal 1 for now. Okay, and then, okay, we don't need this anymore. So we'll do, what was this even checking for? Movie theater age discount. Wait a second, less than 2? Who's bringing a kid less than 2 to a movie? You should have to pay extra for that, not a discount. All right. No, parents need to go to movies too. Just go when no one else is. I guess we don't even go to movies now anymore, right? All right. Anyway, okay. So if you're less than 2 or you're over 65, it'll say ding, ding, ding. You get a discount. All right. And so else you pay full price. Sometimes I code from the inside out. It's so I have time to think of the method in this language. Okay. How did 51 minutes pass? It's insane. Okay. So if you're 1 years old, do you get a discount? I think you guys might know the answer to that. Ding, 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 you get a discount. Okay, anyway, let's double check. You should always make sure. Once you have enough experience, I think you'll not need to do this anymore. All right, you pay full price if you are 5 years old. Okay. Anyway, let's say, what other things are in here? I think you guys get the idea. But all of these examples are only 1 or 2 outcomes, or some multiple outcome ones here. Oh, here we go. This is perfect. Let's see if we can get rid of the drawing stuff here. Okay. This is what I was looking for. A binary tree showing the logic of the bank loan decision process. And so there are 2 ways to be approved, and there are 2 ways to be denied. So 4 outcomes in this case. First of all, they're only going to give you a loan if your salary is greater than or equal to $40,000. That's going to be dependent on how much you're asking for. But in this case, I guess this bank just has one rule. You have to make that much money. All right, and then they're checking your credit score. If it is, wait a second, what? Oh, okay, so if it's less than 600, your loan is denied. If it's greater than 600, we're going to check how long you've been at your job, because we don't want to give someone a loan that's been at their job less than a year, probably because people that have been at their job less than a year are the people that may not have that job anymore soon. And then here, if you have a salary that is greater than or equal to 40,000, we're going to check your credit score here. Oh, there's 6 outcomes. I'm sorry. So if you make enough money and you have a good enough credit score, they give you the loan. If you make enough money but you don't have a good credit score, but you've been at your job for more than a year, they'll approve it. Anyway, you can see there's 6 different outcomes. We can't just do something like if salary greater than 40,000 and credit score greater than or equal to 600 and months at job is greater than 12, loan approved or loan denied, because we have this extra condition up here that we need to include in. So that would require nesting. Or did they fix it down here? Nope. I don't think you could make that any more concise than using nesting. Here's a challenge for you. See if you can convert this so that you don't have to use 1, 2, 3, 4, 5 if statements. See if you can reduce that down. That'll be a challenge for you. If you can do that, then I'm pretty sure you can reduce it down with some complex conditions. For example, they're always checking the credit score. No, because this would be much better if this was in the if and that was in the else. There's just always code happening in these. Anyway, if you can figure out a way to make it more concise, there's your challenge. Try to do it in less than 5 if statements. But these would be nested. And so you need nested if you have more than one outcome. And in this case, there's only 2 different outcomes, loan approved or loan denied, but there are multiple paths to reach that. All right. So anyway, let's talk about functions. Anyone in here already been using functions at all in JavaScript? So we've been using functions all the time, but we haven't created any of our own. So console.log, that is a method of console. Methods are just functions, but they are functions of an object. What else? WriteLine is a document.WriteLine is a method of the document object, so that's a function. ParseInt is a function. You've been using a lot of functions already. But how do we make our own functions? Okay. Okay. Global variables. No, let's not worry about that. And let's not worry about this flowcharts or the pseudocode. All right, let's start with functions, and then we'll take a look at modules. Because I think module, let's see, module. I don't know if I've ever used modules, honestly. And then, ooh, this is a good one. Passing arguments by value and by reference. This is extremely important to know in programming. We'll cover that. Oh, and then we'll start talking about debugging also. Okay. We're going to run out of time before we get to modules. That'll give me time to bone up on it. Okay. Is Replit working again? Cross your fingers. Try it again. Experiencing high load times and instability. Well, that's nice to know. All right. So, you know, if something's due and you're having a problem with that, you can just do it in a text editor for now. You can download Visual Studio Code or Notepad++, or you can use Notepad that's built into Windows, though it's not going to give you color code or code coloring. Okay, and this is probably hard to read on a black background, so let me change that. Appearance. And where's dark mode? Somewhere in here. Editor layout. It should be in here. I'll have to find that again. Anyway, hopefully you can see it. So, creating a function in JavaScript. Well, it starts with the word function. And then you, just like a variable, you need to give it a name. So you get to use an identifier. Oh, edit preferences. Thank you, Wyatt. The heck? Is it file preferences? Oh, there it is. Color theme. There it is. Light. Ah, my eyes. Okay. There we go. I don't know why that's easier for me to see. I guess because I've written on in like this, but at nighttime this will burn, you know, this will give you a headache. So there's a dark, I think there's a dark mode in Replit too. So anyway, identifier follows the same rules as variables. So can I do this? No, you can't start it with a number. You know, rule of thumb, stick to alphabetic characters, and then follow the naming convention. So start with a lowercase and then camel case, right? And if you're unsure, because, you know, for example, if you start using multiple languages, and if you're in the programming program, next semester potentially you will be taking web scripting 1, object-oriented 1, and so, you know, people that didn't take Python might be taking Python. So it's 3 languages, and so it's hard to keep track of the naming conventions. So let's go JavaScript function name convention. Coding conventions. All right. Variable names are camel case. We already knew that. Functions also looks like they're camel case too. All right. Da, da, da. This isn't organized very well. Okay. It's simple. Just use camel case. Okay. What do we want a function to do? Let's make a function that puts together a first name and a last name. So we want to give it a name. We'll call it name combiner. All right. And so here's my function, and I can just do something stupid for now. Console.log. I wonder if I can look at the terminal in here running this. That would be cool. Let's see. Function has been invoked. And when you first start working with functions, this is a way you may not even know whether it's running or not, because either there's some logic error that you made, and so it's just not doing what it's supposed to, or you may not be calling it correctly. So if you're not sure, you can just go to the function and put in a printout message in the console, and then you can see that it actually did run if you see that message. Okay, so I've created a function. How do I know if it worked? Well, we can check it for syntax errors. Let's see if this works in here. I don't think it's going to work. What about JavaScript? No, I don't think this is going to work. Run without debugging. Okay. We're going to have to save it. Oh, it's saved. Okay, let's open it here. Maybe I should just use right line. That'd be a lot easier to see, huh, in this case. Okay, so there's no output in the console. What we've done here is not anything more than defining a function. Okay, so let's say you are a automobile company, okay, and you want to make some cars. What do you have to do before you make a car? Let's say you don't have you've never made a car before. Okay, I want to make a car for my automobile company. What would you do? Because everyone knows how to build a car from scratch, right? So you need to design it, right? Before you can make it. And if you design a car, but you never follow that design, do you have a car? No, you just have a design for a car. So a function is basically just a design. Okay. It's not going to run this code until I actually put that design into effect by invoking the function. That's the technical term, but I'll probably just say call. You make a call to the function. That's what most people call it. So remember, nothing is outputting right now because all we've done is come up with a design for this function. We've defined it. So it's not going to do anything unless we use it. So how do you use a function? Well, like I said, you've already been using functions. Console.log, document.writeLine. Excuse me. Okay. Those are functions. And how do we use them? You just call them by name. And by name, you have to include the parentheses. This is part of the name. This is actually, you can think of this part here before the curly brace. This is the function signature. It has all the information about how to call this function. Okay, this tells us it's a function. So I know on this line we're defining a function because it has the word function. You don't have to use that when calling it, only when you're defining it. We just use the name. So if I want to use this name combiner, I can do name combiner parentheses. That's how it knows it's a function. So we can save that, and let's see, refresh the page. Function has been invoked. All right. So now we've called it. Ooh, my ears are ringing. Someone must be saying something bad about me, right? Okay. So the only time you would have you probably wouldn't have a function that prints out. Okay, this is a function you're not going to use very often. What we want it to do is combine a first name and a last name. So let's create some variables for that. Let first name equal Sally. Let last name equal Todd. Okay. We want two people with last names that are first names. Sally is, let's capitalize her name. Well, now I'm thinking about Abraham Lincoln's wife, so I'm changing her name to Mary. And her last name to Todd Lincoln. Wait, was Todd her middle name? I don't know. We're going to pretend that was her last name. Someone look that up. Tell me. All right. And so we want this function to be able to take in two names, stick them together, and then return return that value. So how do we take values into a function? So when we do document.writeLine, we are passing in this. What is this? Here on line 8 that I've highlighted. What is that? Okay, it was her maiden name, but she changed it to a middle name. Okay. So we'll do let middle name. Charlie, did you know that, or did you look on Wikipedia? Only later in life have I gained a respect for history. It's very valuable. It's more than just trivia. Yeah, it's always good to don't be too proud that you're not willing to double check your information. A lot of people are gonna hear things. I mean, you guys probably know what I'm talking about right now, but there are people, a majority of people hear things. They don't understand what the source is, and then they repeat those things as if they were fact. And then people that hear them, well, they said it very confidently. You should always know the source of what you're listening to, and don't repeat it as if it's true unless you know. Okay. So how do we get values in there? Okay, so this WriteLine function, we just put this in here, and what is this? This is a string literal. It's a literal value of the string data type. So this WriteLine function takes in one argument, which is a string. It probably has another way to deal with. If you just put in numbers, right? It works still. In this case, not every programming language is going to allow that. JavaScript is a very loosely typed language, and it's meant to be as easy and simple, and it has a lot of problems because of that. But as long as you understand, you'll see next semester when we work with C#, which is one of the stricter languages, that you'll hate it first, but it's very valuable knowledge because you have to understand a lot about computers. Anyway, so we can put in a value here, but we want in our function the ability to put in a first name and a last name. So we need to define parameters. So this is the function name. Back here. And then here are our parameters. And so you can think of this as basically creating variables. Okay? What variables should we use if we're going to take in a first name and a last name? How about first name and last name, right? And I'm going to try it this way. I don't know if there's... You always separate your parameters or your arguments with a comma. So now the function signature here, this is like a promise. Okay? Whenever you use this function, you're promising that you will give it exactly 2 values to work with. All right? And by naming them first name and last name, you're reminding yourself what is trying to go in there. And if anyone else wants to use this code, they'll be grateful you didn't call it X and Y. There are times when you would use X and Y for coordinates, for example. For storing first names and last names, probably not a good idea. So we can take those in, and what do we want to do with those? Well, for now, we're just going to print them out. First name plus last name. And we want a space in there, so we can do this. So now, what are these? These are our parameters. Down here, we're calling the right line function. We're giving it one argument, because it takes in one argument. That argument is the result of this expression. And this expression has a variable, a string literal, and another variable. And so for this to work, we need values in these two that can be converted to strings. And so first name we know is going to be, we want to pass in Mary and Lincoln and put a space between them. So this will give me an error because now I'm trying to remember the method signature, and we'll put that here. Method signature. Oops, I could have gotten rid of this a long time ago. Okay. In the method signature, we're saying we promise we'll give you 2 values. Well, down here I'm not giving it any values. Let's see what it says. Okay. This is one of the problems with JavaScript, is that it didn't give an error, but we definitely did it wrong. So let's go and pass in first name and last name. And you know what? This is probably really confusing because we have first name, last name here, first name, last name here, first name, last name here, and first name, last name here. So I'm going to change it. We'll call this one first name and last name. Just so you guys can see where things are coming from and where they're going, we're going to do it this way. F name and L name. So I'm gonna explain here what the computer is doing as it reads this code, and then I'm going to, depending on whether I talk about that for 10 minutes, hopefully not, I'm going to create a diagram that's going to show you what's happening inside the computer when you do this, so that you get more bang for your buck. Anyway, let's test it first. Make sure it works. Mary Lincoln. All right. So you guys know what this is doing. We are declaring a variable called first name, and we're assigning its first value. So we're declaring it and initializing it as Mary. So that's a string data type. Doing the same thing here and here. So we have 3 variables that contain strings. What are we doing here again? We're just we're defining the function, what we want to happen when we call the function. That's all this does at this point. It does not run the function, does not call the function, it does not invoke the function. It's defining it. Okay? And so also, as you're reading code, you need to be able to identify these things quickly. So how do I know this is a variable? You guys have been looking at these long enough. There's all kinds of things about these that tell you it's a variable. We're assigning a value to it. It has let or var in the beginning. This is one nice thing about JavaScript. How do you know this is a function? How do you know this is a function definition? Well, it starts with the word function. All right, and then we have our name. We have to give it a name and parameters. Okay. 0 parameters is acceptable. But if you need values to go into the function that you can manipulate, then you need to provide parameters. And so whatever you name, you get to choose the names for the parameters. And then you can reference those inside of the function. Sorry. My mind is slowing down. Okay. Then what about down here? What is this? Calling the function. So when it gets down to line 14, you can imagine that it's going to do this. It's going to say, okay, I need to run this function, and I'm going to give it the value inside of this variable, which is first name. See how it highlighted that up there? It's just showing me this is also the same set of words, but this first name is coming from this variable. It has nothing to do with the function right now. Last name, where's that coming from? That's this variable. Calling the function and passing in variables for the arguments. So if I define my function with 2 parameters, I'm promising that I will provide 2 arguments. Okay? And, I'm not sure why they're called arguments. It has to do with logic and mathematics, probably. Anyway, or language, some weird definition there. All right. So here it's saying, okay, I'm going to use this function, I'm going to use this value and this value as my arguments. And then what does it do? Well, then it's going to run the code in here. And so it's going to take the value in first name, Mary, stick that in F name. So see, here we're passing in the value in first name, and then from there, it's passing it into the function, into this slot. So the first value goes in the first slot, the second value goes in the second slot. Okay, and so it's going to say, now I can just reference these variables. Inside of this function, we have a variable called fname and a variable called lname. We've declared those up here, and we've assigned them the values down here. This is very confusing for new programmers because you're used to procedural code that's going to go from top to bottom. But now, every time you call this function, it runs this code. So it's going back and running that every time. So now you can use a function more than once, obviously. Let's do this, and we'll change it to last name, first name. Save it, and run it. Mary, Lincoln, Lincoln, Mary. All right, and then remember, if you're outputting to HTML, you need to include a line break. The HTML element, the break element. All right, and you can do it as br // which makes it backwards compatible with older browsers, or you can say, you know, if you can't have a modern browser, I don't want your business, which no one would ever say. But you get to make that choice. Okay, Mary, Lincoln, Lincoln, Mary. So remember, these are just names. So even though I'm putting the value from last name there and first name there, it doesn't. The function doesn't care. All it's going to do is take whatever value you put in here. I could put 7 and 38, 378 in there. Okay, 2 values, 7 and 378. Okay, put any values in there. All right, so defining a function, using a function. At this point, it probably doesn't seem all that useful because I could do the same thing by just copying this line twice, right? Doesn't make it that much more concise. But we'll look at more complicated ones next time. But so I don't want this function to print things out. I want it to have one job. Just put 2 strings together for me. So I don't want to print it out anymore here. Because what if I want to use, what if I need to use that full name somewhere else? You can have a function return a value. Boop, 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 by using the word return. Okay, so if we do that, I'm going to comment this out. We don't want to, this is like a robot name, 7378, or like a prisoner number or something. Okay. We're going to pass in these 2 values. That's the same, but now instead of printing it out, we're going to return them. What is that going to look like? Nothing. Because we're not printing anything out anymore, right? How can we print this out? Because this just returns a value. So when it gets to line 14, it passes in Mary and Lincoln into here, and then it puts them together here, and then it returns that value back wherever this is. But we're not doing anything with it, so it just disappears into cyberspace forever. If we want to print it out here, we can do that. Document dot write line why did I get rid of my write line? That was weird. Okay, and just we can nest these functions like this. So now it looks really confusing, right? But you have to be able to understand order of operations using functions and expressions to see what's happening. So when you nest your functions like this, you just follow the parentheses just like you know, PEMDAS or normal math operations. It's just the parentheses first idea. So we're going to write line whatever is inside of here. Well, we can't do that until this function is done running, and that can't return a value until it passes these into here and it runs this. Then it will take that value, spit it back out into here, and so this will break down into, you know, in math when they say, okay, show your work, you're never going to do this in programming, but I just want to show you this is what it's going to become. Right? Because this is going to return this value, and this is an expression. It's just concatenating all these strings together. And so it's going to return that. That'll become here. Oh, and it'll do this too, right? To be more accurate. It's going to return that. And what is it going to do after that? Well, it'll just spit it out. So this is all we need to print that out. All right, there's that. Okay, now I really have to go set up my next class. So we'll continue this next week. But if you want to practice, just go back to any previous program and try converting some of the tasks into functions. Any program where you're repeating a lot of the same code is the perfect place to use a function. All right, I will see you guys next week. Don't forget, you can, if you're a programming major, you need to schedule an advising meeting with me. Registration starts on November 9th, so you won't be able to register until you meet with me, and I've got open times on my schedule. Just email me and I'll help you out getting that started, or message me on Canvas. That's fine too. All right, have a good day, folks.